Hey guys, this is Eddie the Magic Monk doing a lesson on binary numbers. And just before you ask, Eddie, why are you doing another lesson in binary when there are already hundreds of videos on YouTube talking about binary numbers? And the reason for that is because I had to teach binary numbers for my class, and I showed quite a couple of videos from YouTube to my class, and the students were still quite puzzled after watching the videos. And then I did something with them on the whiteboard, and after I went through it, they actually understood it a lot better. So I thought, okay, well, I must be explaining something right, so I thought I'd just make my own video. So this is what you will learn from watching this video. Number one, you will be able to count in binary. Okay, so for example, normally we count 1, 2, 3, 4, 5, 6, and after watching this video you will be counting in 0, 1, 1, 0, 1, 1, 1, 0, 0, and so on, and you'll understand why you do that. Okay, and be able to convert decimal numbers to binary and vice versa. So for example, if I give you a binary number, for example 1110, you will be able to convert it to a decimal, so you will know that this number is equal to it is equal to 2 plus 4 plus 8, which is 6 plus 8 is 14, and you will understand why that is. Okay, this is not the tutorial yet. This is just showing you what you will be able to do by the end of the tutorial. Okay, so here it comes. So this is the number system that you are used to when you're counting objects. Okay, let's say you have one single butterfly. Okay, I'm just going to draw one single butterfly on the page. Right, this is represented as 1. And actually, let me just draw it all out so you don't get confused. So when you're counting normally, if there's one butterfly, you write the number 1. This is the symbol that you use to represent the butterfly. And in base 10, we have a symbol for 2 butterflies. We have another symbol for 3 butterflies. We have another symbol for 4 butterflies. All the way to 9 butterflies. Okay, now what happens when we want to add another butterfly to 9 butterflies? Well, we've run out of new symbols to use, so therefore we increment to the next digit, so we write 1, 0. Okay, so now we have 2 digits, and then we add another butterfly, so we have 11 butterflies, 12 butterflies, and all the way to 99 butterflies. And then what happened? We run out of digits, so 99 plus 1, we increment to the third digit, which is now the hundreds. So now we have 100 butterflies. Okay, and then we have 101, 102, all the way to whatever. So that is the base 10 system. Now let's talk about the binary system. Okay, so again, actually I will just write it right next to it if you don't mind. So that is the base 10. Now let's do the binary. Okay, so 0 is still 0, 1 is still 1. Okay, now what happens to 2 butterflies? Okay, the number 2 does not exist in binary. Neither does the number 3 or 4 or 5. None of these numbers exist, because binary means that only 1s and 0s are allowed. Okay, so none of these numbers exist. So what happens is we have to skip all of these numbers. We have to skip all of these numbers from 2 to 9. So the next number available to us will be 10. So we have to increase to another digit. So basically in binary, 0 plus 1 becomes 1. But 1 plus 1, okay, normally it would be 2 if it was decimal, but because this is binary, 1 plus 1 actually becomes 1, 0, because you have to increment the next digit, because there is no 2, so it becomes 10 or 2. This number means 2 in binary. Okay, so what happens is 1, 0, so plus 1 to give us 3, right? 3 doesn't exist, so it'll be 1, 1, right? If you guys have a look down the decimal system, after 10 there is 11. Okay, so what would number 4 be? Well, number 4, okay, every single number between 12 and 99, they all have a number between 2 and 9 in it, so they are not allowed in binary. Only 100 is allowed in binary. So if we have 1, 1 in binary, add another 1 to it, it will become 1, 0, 0. Okay, so similarly, following these rules for addition, 0 plus 1 is 1, 1 plus 1 is 1, 0. So then I will be 101, because you're adding a 1 to the last digit. Okay, so 5 will be 101, 6 will be 110, 7 will be 111, 8 will be 1000. Okay, so that is how you count in binary. So hopefully you now understand the first learning goal. You are able to count in binary. If you still don't know how to count after that, feel free to send me an email, and I don't know how else I can teach you, to be honest. Okay, so now, what if somebody says we want to convert the number 39 to binary? Okay, so I guess what you could do is, if you had a lot of time, you can just keep counting up. So 9 is 1001, 10 is 1010, 11 is 1011, and all the way, and eventually you'll get to 39. Okay, if you didn't know it, if you didn't know how to do it an easier way. Okay, but there is an easier way, and that relies on these particular numbers here. A 1 in binary is equal to a 1 in decimal. 1, 0 in binary is equal to 2 in decimal. 1, 0, 0 in binary is equal to 4 in decimal. And 1, 0, 0, 0 is equal to 8 in decimal. So let me write these important numbers out, because we need them in our conversion. So from binary, a 1 is equal to decimal is a 1, but a 1, 0 in binary is equal to a 2. 1, 0, 0 in binary is equal to a 4. 1, 0, 0, 0 in binary is equal to a 8. So what that means is, when you have a binary number that has a 1 in the first digit, it equals 1 in decimal. If you have a binary number with a 1 in the second digit, then it means a 2 in decimal. So if I give you a number like this, okay, let's say I give you 1, 0, 1, okay, in binary, and you're trying to convert it to a decimal. Okay, what you would do is you would recognize that the first digit in binary is equal to a 1 in decimal. The second digit in binary is equal to a 2 in decimal. And the third digit in binary is equal to a 4 in decimal. So because the second digit is a 0, we ignore that. So the decimal equivalent will just be 4 plus 1, which is 5. So if you look up back in the chart, okay, what is 101? 101 is a 5. Okay, so let's try 111. So if we have 111, okay, the first digit is a 1. Alright, the first digit is a 1, the second digit is a 2, the third digit is a 4, right, according to this. So we have 1 plus 2 plus 4, which is 3 plus 4, which is 7. So 111 is equal to 7. Now let's check. Yes, 111 is equal to 7. Okay, so let's give you a huge number and see if you can do it. So if I give you, for example, 11011001, and I ask you to convert it into a decimal number. Okay, so what are you going to do? Well, because the first digit is equal to a 1, the second digit, okay, the second digit, if it was a 1, would be 2, the third digit will be 4, the fourth digit will be 8. So you can see it's multiplying by 2 every single time. So the fifth digit will be worth 16, and then this digit will be worth 32, this digit will be worth 64, this digit will be worth 128. Okay, so wherever it's got a 1, okay, that's the one that those are the numbers that I'm adding. So I have a 1 here, so it'll be 128 plus 64 plus, I'm ignoring the 32 because it's got a 0 here, plus 16 plus 8 plus 1, because these two are zeros, so they're ignored. So what is the answer from that? 217. Great. Okay, so now that you know how to convert from a binary to a decimal, if I give you a random decimal number, so let's say I give you a decimal number that is, let's say 42. How do I convert this to a binary number? Well, if you guys remember, okay, a binary number, okay, the first digit is worth 1, the second digit is worth 2, third digit is worth 4. 1, 2, 4, 8, 16, 32, 64. Okay, all we have to do is think to ourselves, does 64 fit in the number 42? No, so it'll be a 0. Does 32 fit in the number 42? Yes, so I'm going to put a 1 here. So what do I have left? 42 minus 32 will be 10. So I have 10 remaining. So I can now see, okay, does 16 fit into the number 10? No, so put a 0 here. Does 8 fit in the number 10? Yes. So 10 minus 8, I have 2 remaining. Does 4 fit in the number 2? No. Does 2 fit in the number 2? Yes. 2 minus 2 is now 0. So does 1 fit in the number 0? No. So that is the number for 42. This is the binary number for 42. Okay. The 0 at the front, you don't have to write it. It's still the same thing. So 101010 equals 42 in decimal. So this is the binary and this is the decimal equivalent. Okay, thanks for watching the video, guys. Hope this video helps you. Let me know if you have any more questions. See you later.